Welcome, physics people, to another video on Newton's laws. In today's video, we'll be looking at connected bodies. So here you can see we have a tugboat pulling a large ship, and both of these objects are connected by a cable. So let's have a look at some questions regarding connected bodies. So the scenario we have, a 2-ton tugboat is pulling a 20-ton ship out to sea. The tugboat's propeller provides a driving force, Fd, of 55 kilonewtons. The tugboat has a frictional force of 1 kilonewton, and the ship has a frictional force of 10 kilonewtons. The two vessels are joined by a cable under tension. Task number 1. We're asked to construct a labelled force diagram of the connected tugboat and the ship. First of all, we're all aware that any object with mass is attracted to the Earth with the force of gravity. So the tug has a force of gravity, Fg, as can be seen, and the ship also has a force of gravity, Fg, as can be seen. And we're using the subscript T and S to identify the tug and the ship. Fg, the force of gravity for the tug, little t, and force of gravity for the ship, little s. Now there's also another force, Fb, of both the tug and the ship. These forces represent the buoyancy force. The buoyancy force acts much like the normal reaction force of a solid object, in that it opposes the gravitational force in the opposite direction. It's equal in magnitude but opposite in direction. We also have the friction force. There's a friction force of the tugboat and the friction force of the ship. We also have a tension in the rope, which can be considered going to the left from the ship's perspective and going to the right from the tugboat's perspective. Finally, we have a driving force. The driving force, Fd, is being generated by the propeller and moves both the ship and the tug to the left side of our diagram. Task 2. Calculate the net force Fn on the tugboat and ship system. We know that motion is in the horizontal plane, moving to the left, and so first of all we can cancel out the vertical forces. The buoyancy force Fb and the gravitational force Fg will cancel out for both the tug and the ship, so they disappear. Also, the opposing tension forces Ft will cancel out when we're considering the tug-ship system. So we're left with a more simplified diagram now. So at this point, let's consider the tug and the ship as one single system. We can see this system consists of 3 forces only. First of all, the driving force to the left, the frictional force of the tugboat to the right, and the frictional force of the ship also to the right. Let's simplify that. We have our one system generating a net force to the left, which is being produced by the driving force of the propeller of the tugboat and being opposed by the 2 frictional forces of the tugboat and the ship. Let's write that as an expression. The net force is equal to the driving force, take away the sum of the 2 frictional forces. Let's put our numbers in, 55 kilonewtons for the driving force, and we've got collectively a 10 and a 1 kilonewton of frictional force. That adds up to give us 11 kilonewtons of resistive frictional force. So in total, 55 take 11 gives us 44 kilonewtons to the left is our net force. Task number 3, let's calculate the acceleration of the tugboat ship system. So again, we're looking at the one system, and we know that the net force is 44 kilonewtons. We're asked to find the acceleration of the system. We know the net force in the system is 44,000 newtons to the left. We know the mass of the system, that is the ship and the tug combined, is 22,000 kilograms. The equation we have is F net equals ma, standard Newton's second law. We transpose that and we find the acceleration is equal to the net force of this system multiplied by the combined mass of the system. That gives us a value of 44,000 over 22,000, which results in an acceleration of 2 meters per second to the left. Finally, task 4. Calculate the tension Ft in the cable between the tugboat and the ship system. So we're looking at these values. In order to calculate the tension force, we need to analyze only one object. So for now, let's consider the ship. We eliminate all the forces associated with the tugboat, and we're left with our forces associated with the ship. We know that the net force of this ship is to the left, and that's being generated by a tension in the cable and opposed by a frictional force of the ship. So we want to find the tension force in the cable. We know the mass of the ship is 20,000 kilograms, or 20 ton. We just calculated the acceleration of the system, and therefore the ship is 2 meters per second, and we know the frictional force of the ship is 10,000 newtons. So the net force is equal to the tension minus the frictional force of the ship. Net force can be expressed as ma, Newton's second law, so that's equal to the force of the tension, take away the force of the friction of the ship. In order to get the force of the tension by itself, we need to get rid of this force of the friction of the ship. We'll add that across to the left-hand side. That leaves us with the force of the tension is equal to ma times the force of the friction of the ship, and we can sub our values in. The mass of the ship was 20,000, acceleration was 2, and the frictional force of the ship was 10,000. So that will give us 40,000 plus 10,000, resulting in a tensional force of 50,000 newtons to the left. We could also have approached this problem by focusing on the forces associated with the tugboat, because it too has the tension force, which is equal to the tension force being generated by the ship. So let's repeat this calculation and consider the tugboat. So here's our diagram. The net force again is to the left. That's being generated by the driving force of the propeller and being opposed by the tension in the cable and the frictional force of the tugboat. So a slightly different looking equation because this is a different looking scenario. First of all, we want to find out the tension, Ft. We know the mass of the tugboat is 2 ton or 2,000 kilograms. We know the acceleration of the tugboat is 2 meters per second. We know the frictional force of the tugboat is 1,000 newtons. And we know the driving force of the propeller found in the tugboat to be 55,000 newtons to the left. So here's our expression. The net force is equal to the driving force, and it's being opposed by the sum of the tension in the cable and the frictional force of the tugboat. Net force can be expressed as ma. Now we are trying to calculate Ft. At the moment it's being subtracted, so we'll add that across the left-hand side. We can do that now. And we're after Ft by itself. Let's subtract the ma and the frictional force to the right-hand side, which results in the force of the tension is equal to the driving force, take away the sum of ma plus the frictional force of the tugboat. Let's sub our values in. The driving force was 55,000, the mass was 2,000, the acceleration was 2, and the frictional force of the tug was 1,000. When we do our calculations, that also generates a tension force of 50,000 newtons, as it did in the previous analysis of the ship. However, the ship's tension was to the left, and the tension of the tugboat is to the right. And that makes sense, because our diagram here shows the tension force to the right.
You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.